Okay, it looks like we're live, so welcome back. Today I'm going to be continuing to work on Kano script. Okay, so today I'd like to move it apart so that it's not in the same repo as my virtual machine, right, Tim? And then I want it to be more independent, right? So I'm going to take the take this Tim.c and Tim.h and put it into the source, right? Right, so they are going to diverge a little bit because there's specific needs that this needs that aren't necessarily required in the actual virtual machine. So let's see. I want to make it into a header-only library because it's not very much, like 1,000 lines. It could be even less, right? Because there's kind of a lot of extra stuff here like this. And I think that would make it nice. Then I can just import it, just include tim.h, and that would be very useful. So I think what I'll do, grab that. Uh-oh. I did it. I accidentally did it twice, I think. Yeah. Undo that. It's gonna take a second. Okay. Hey Tim, how you doing? Oh shoot, I think I opened the wrong file. Let me start that over. I did indeed. Resubscribed with Prime. Thank you, Tim. Appreciate that. You are fine. Alright. How is your text editor going? I saw you doing some work on that. PED, P-E-D. Yeah, yesterday. Did you get the insert mode working now? Because I remember you said it wasn't working, but then was not sure. Didn't really contribute the past day. Got a corn and we got a cob, yes. Or the past day, yeah. Okay. Shit. How are you doing, Anthony? Coming in to say hi? Well, hello. How is Shard going? I've been looking at the source code of it. I've not contributed, right? I don't feel that I could yet, from what I know. See ya. Alright, have a good one. It's kind of working. Okay. Making website. Alright, alright. But try it? Yeah, I'll try it out in a moment. Docs. Yeah, docs that'd be pretty helpful, probably, for contributing, right? Because that was kind of unclear, like, where, to me at least, like, how to get started with the next stage of it. If that makes any sense, like, actually implementing stuff. Yeah, so docs and things like that would be quite helpful. Got a link spec. I'll hit you up. Alright, yeah. Have a good one. Have a good one. Sounds good. And yeah, so this is for Tim H. Let's see, that's what it is. Yeah. Alright, and then I will do whoops. If define Tim implementation when this stuff and if that is almost done. Alright, see ya. Have a good one. Have a good one. Okay. So if I go ahead and remove min.c, because I have all that now. Let's go to min.c and I try to include it. Right. Why did that? Okay, yeah. Completing types for string view. So I can probably might be able to get rid of it. Yeah, so I'll try it out in a moment. Tim, for sure. Yeah, there's gonna be a couple conflicting types here. View actually, I can't really do that, can I? View.h, can I do that? Okay. Data pen redefined, so I can get rid of that as well. Perhaps I could include deps.h instead. Get rid of this. You know, we need it anymore. And probably print error as well. Shoot, but that is different. So I might want to change the name of that one. Yeah, so print error, that's going to be different because that's a runtime thing. So, no character, no, that's a copy paste issue we've been seeing. Okay. Yeah, so I can just fix that. First, I do want to try this out. Let's see. So I have it actually on here, on the system. Create a release on Canada. No, I didn't really change anything. That was just from here on out. I'm going to be creating releases once there is, like, over certain periods of time. But that was just, like, the initial one. Even though I didn't push anything new or anything like that. To make it easier to manage in the future. Let's see. Yes, I do need it. So can I fetch or pull? Okay. And I have to. Alright. Run that again. Okay, and then let's see build. Okay, nothing to be done on it, so I think I have to do this. Make sure it's rebuilt. And then, yeah, I'm not going to install it. So, ped file out txt. Okay. Alright. And segfault. Okay. So I guess cannot insert in the middle. That could be an issue. Yeah. Let me start with a new file. Alright, insert. How do I insert? That's normal mode. How do you enter insert mode? Let's see, usage, normal, insert. Alright, here we go. Let me minimize this. So how do you enter insert mode is A, okay. Alright, I cannot type, it seems. How do you type once you're in insert, or can you not do that at all yet? And let me try something. File with multiple lines. Alright. What the heck? Alright, I'll try that and then okay. Okay, can navigate here, line numbers. I can insert right there, alright. Can I insert there? Okay. That works, seems to work. Alright, and then I think, so yeah. That actually did work, okay. Almost worked. Alright, I guess you can just, that's interesting. Okay, yeah, well, so I see it does work. Just not with an empty file. You can't, properly create a new line, that must be what that issue is, right? Yeah, okay. Right, you can insert them here, but alright, that makes sense, Okay, yeah, very cool. Coming along. Yeah, pretty much. Yeah, I understand entirely, of course. As you know, buggy text editors. Know a thing or two about that. I want to replace air with probably. Alright, now if I build it. Don't think it's safe. There we go. Okay, so this is compile. So I guess there's no other things that are conflicting. But I like the type though. It's not going to conflict in here, but it might conflict in the. Well, no. Yeah, I think it should be fine. Alright, so. Now working on it right now. Still configuring desktop. Alright. What is this? Get rid of this. So what configuring are you working on at the moment? Okay, let's see. Yeah, so I basically want to just call to this. So, let's see. Open. Let's see, if I go in here, I can't really do that, can I? But I could go right here and include. This might not work. Include team.h. Is that going to work? So I'm going to need it in here, right? It does compile, okay. Watching video about Polybar on Awesome right now. Alright, that's nice. So I need to declare a machine here. And let's see, how exactly do I handle that? Because I need to really open a new one. It's going to be similar to what I have in here. Right, all this stuff, but first of all, we create a machine. I guess we allocate it, but I don't think that matters. Pass a pointer to it, read it from the file, so we don't need that. We're going to write it to the file. Basically going to build up the machine. So yeah, we can allocate it like that. And then we'll have to pass it around to every single one of the things, right? So let's say this one, right? Machine. Pointer to the machine right here. Then we're going to push the argument. Actually, do we really need that? Really, we need just the let's see, how do I want to handle that? Let's take a look at the machine, perhaps. So we have the list of instructions. So we can just DA append to that. DA append each instruction. And the instruction has a few things. So that's basically what each thing is going to be. So yeah, let's pass that to the machine. To here. I'm going to generate the variable. So gen variable declaration. Okay. Basically, all the gen functions are where we're going to do that. Right here. So let's see. When we are doing this, we want to push these things. Let's see. Are we actually creating any code here? We are not. So we'll go one level higher, and we'll start with, say, gen, right? So this, the machine could be a member of the state, and then we don't have to pass it all around. I think that makes sense. So let's see. We have the state and the the state would work, yeah. Which is the program state. So let's add machine here. Be a pointer to it. I think it can be like that. Then we don't have to pass all that stuff. That would be good, I believe. Because we already passed it here. So let's go to gen whatever. Okay, so right here. So this can be DA append to the state machine dot instructions. I want to append a push instruction. So it's going to have those things. So where is the inst? Right here. So this doesn't matter. We have the data type, the value, and the instruction type. So let's create an instruction here. Actually, it's inst, isn't it? Yeah, inst push inst equals instruction. So it has a few things here. So basically, we have, where is it? We have the type, which is the instruction type. So dot type equals inst push. Dot value equals value. Right? Is that, well, the value is a word, right? Dot value dot as int equals value, and then dot data type equals type int. That one's called type int, or I think it's int type actually. Int type. Alright, and then that is what we want to append. We want to append push instruction. Okay, and then let's comment that out for now. Let's see if that will go ahead and compile. Data append. Alright, there already is a pointer, so we do not need that. Inst has no member named cat. Okay, shoot. So it's not a it's not an array like that. So that's not quite gonna work. Right, because it's not a It's not a dynamic array. Let's go out here. But we have inst. Yeah. Oh yeah. It's just an array like that. So to change that, it's gonna be. Would it be that hard? Let me see if I can do that, because I'd like to be able to just get it. Okay. Basically, I will make a inst. Let's see. Okay, yeah, so this will be a dynamic array. Whoops, I don't mean to do that. Inst, there we go. And this was have inst instructions. Here. Let's see, count and size the capacity. Size type capacity. Okay, and then that's what we're going to use here is instance. Like that. And that is going to break some stuff, so I will need to fix where it breaks. So I'll save this. And go here. And let's see. So, yes, we're failing on these parts. So let me go back. Let me go back to this, and then comment this out. And go through all of these. So, well, no. Okay. Yeah, it's not instruction, it is inst. Code for PED isn't working that great as of right now. You can see. But did you read the theory I wrote in the read? You mean for the in terms of this, right? I did read through some of this. Unless you changed it since I read it. It seems longer. I did not read this much. Yeah. Yeah, I looked at this. Yes, indeed. Right, change references. Right, yeah. That you are no longer storing new line. Oh, okay. Okay, I see. Wait, so how do you handle the new line then? Oh, it's two-dimensional. Okay, I see. That makes sense then. Right. Yeah. Makes sense. I think it could be a decent approach. Like, obviously, there's trade-offs and stuff, but I think it could make it more usable in a lot of certain scenarios where a lot of other text editors, such as Kano, right, would be lacking. From their files, so I can just cast that. Okay, we'll push inst. And these are comments. But the rest of it does compile. That's kind of strange, right? But this is now a pointer, so I do that. Also, I need to implementation, right? And then we're gonna get some issues. Let's see. Just iterate over every line I save and give a Y offset using encryptions. Move W, print W. Yeah. That is the name. Okay, makes sense. So it's not like that because so I can't use that. I need .data, right? So I do have to change that. That is what I was hoping for. So maybe I will use vim for this, right? just select this and any machine arrow instruction and replace it with machine arrow instructions dot data. Alright. Need a pointer set the line. Why is it not used? It says no member named data. Wait, what did I call it? It should be called data. That's what I'm calling it. Machine instructions on. Yes, that's the same thing. That's all the ones before it. So I probably replace the whole thing. I don't think there's any place for that one. Instructions. Machine data. Okay. And what is this? Dot data dot data. Shoot. I accidentally replaced this one as well. Let's see. Kind of a long function, eh? I can just replace data with just data. And what is this? $6.27. Read into stir data. Okay, yeah, because it's cons. Okay, so we need to actually do that a bit differently. We need to declare a string and then point it at it. Right, because this is a stack of these. So let's make this a star. Len equals chain sir stack I dot len. Alright, if read into string len. Let's see. Yes, that's the length of it. So read into that, just into len. Allocate this. Read into string. And then we need machine stir stack. Alright, so I don't know why I'm allocating that and then doing that. But yes, then we don't need this here. Or this, so 0. And then we can set it. Machine stir stack I equals do create from stir and len. Stir on this. This needs to be star stir. It's just len. And then it compiles. Okay, yeah. So that should work then. And let's go out of this. Go back to Backend C and try to do this now. Because that should work. Okay. Inside number and capacity. Alright, I spelled capacity wrong. That's nice. Machine capacity. There we go. Then it does the file. And if I run this, okay, we segfault. Why did we segfault? Probably something to do with this. So it's kind of hard to test it if we have. Alright, well, I can replace all these, and it shouldn't be too hard. So we're gonna. This could be a function, right? So this would be inst equals create inst. And we pass the type, so let's push the value and then the type. Okay, so then we can make this a function up here. So int, and that is going to take a type. It's going to take a word value, and it's going to take a what is that type called, right? Right, which is int type. So type. Data type. Okay. Data. I did not use an underscore, and that is very not good. I'll change it later. D type. Okay. Then we can just return type equals inst. No, not type equals type. Dot value equals value, and then the type equals the type. Okay, and we can do this then. Well, actually, okay. So yeah, this is going to be value. So this value that we're going to put is word value as int equals value. Okay. Then build that. We have some issues on the variable ints. Yeah, that is what I want to use here as ints. It's not like this. Oh, that needs a semicolon. Okay. Inst type. So what is it called? Expression set. Okay, why did I call it that? Weird. Data type. Then it compiles, and if I run it, it still cycles, and it's expected, right? Because we're iterating stuff here, so we're probably trying to interact with stuff. So let's do that for the rest of it. So it's going to be similar. So create instruction. This is inst. Let's push a float. So as float equals value. This is float type. Okay, and then, well, if we don't comment this out, it's just so generates out, right? And then we can generate both of them. So let's see, what do I do here? And what do I have for this? Let's go to here. Yeah, so we initialize the state like that with 0. That should be okay. Okay, state, and let's see what else. And I'll get rid of all the printfs later. Get that. Create instruction. So this is another push, but it is a string. How does that work? Oh, it's for a character. Okay. That is a bit harder, right? Because it's a string view. How can we? This may not work for now. Shoot. How do I do that? Because it's multiple characters. I didn't really think about that, so I will just for now insert false. Insert false. Alright, so I'll get to implementing that. Getting it to work. Need to think about it. This one will be easy though. Right. Inst pop with no anything else, right? I just do 0 and 0, right? Okay, it doesn't like that. Okay. Redefinite. Alright, now it is complaining about this. So, is that because of this? I don't really need that in here. Okay, now we're getting linker errors. Hello, Stan. Hello. How are y'all doing? Move print W, move W, print W, chat, 00, hello. Compiler or interpreter? It is a compiler to a bytecode of a virtual machine, which then gets interpreted, similar to like Java. similar to that. So it's kind of both, but really it's not a compiler to assembly, so I think it's more considered an interpreter. Let's see. Let's see. Multiple definitions, right? Where is it? First one, in backend C. Wait, what? Alright, so it is not like that. Okay. So, well, only including it once though. Right, it's not in there. But so let me see. This is the header stuff. We do have assert twice though, so I don't know that that's good. Is that a header file created? No, that is the name of the virtual machine that I'm using. I just called it Tim. Probably gonna change the name though because it's not really accurate anymore. Did I do this wrong? Whoops. Okay. So it's reading it there, but then where is include again? Okay. Multiple definition, right? Detect.h coming soon. Yes. Yes, sir. So what if I move it to here, right? Uh-huh. Just like that. H. Okay. Does not work. Okay. That is not infected. Right. Okay. Do I define that somewhere? Okay. Let's see. So this one is not implemented now, so that's why that goes off. But if I do not do this, then I just want to make sure it will run properly. Yes. Okay. So hopefully it's working. So that's gonna do that, and then this create the instruction, and we can do it again here for add. So add is gonna be similar. Add with no operands or types. Same with sub, so that is rather similar. No. Divide. And there's mod, I think that is the last one of it. Okay, I guess we don't have that. So then push stir. So that's gonna be a bit different because we have to keep track of that differently. Because basically we push it onto the string stack, and then this has to be an index that we actually use for that. So this will be not implemented. Yeah, so it's gonna take a little bit more effort for that. So I will come back to that. This is just SS, and that's it. Today I discovered an interesting thing about my Ubuntu machine terminal. When you press arrow up, it brings you to the previous command. On my machine running an encrypted program, it copies previous screen buffer to the screen. Really? And this is the default Ubuntu terminal? What is... This is Kubuntu. What is the... Is it just the GNOME terminal? I haven't changed anything. And you're running GNOME, right? Is it in the Arch user repository? Should be GNOME, okay. Hang on, I'm gonna install that. I want to see if that works on here too. Okay. That is white. Alright, both Windows and Linux. Is there a dark mode? I don't know how to do that. Okay. I want to try with Kano. Yeah, it doesn't do that, but I handle the up arrow, so yeah, so I guess I don't really have a way to test that because I don't have one that doesn't handle the up arrow. That is interesting. MinGW, okay. That is very weird. Indeed, this does not have an operand either. This one as well, so that is gen's stack size. Then push, then set. Alright, it's actually okay. Ooh, then this is gen. Oh shoot, because we pushed that, so we push the value. But then we need to sub, so that's why I have to do that. So that's not great. Right, this does actually more than that, so I need to keep track of that. So I need to do the first one and then append another one. So this one is actually push. What if we gen push? Well, no, we gen push, so we don't need to do that. Hang on. Let's go back to the okay. And this I need to generate for the NV. Okay, there we go. Now I've got that idea. In swap, same view. I think we have the same thing, right? Yeah. Okay. Zero jump. So label this again is gonna be a bit different. So yeah. I'll get back to that because I have to keep track of labels because they don't exist in the bytecode. So I need to basically just keep track of the index. It shouldn't be too difficult though, but I will come back to it because it's going to be more complicated than just this. And this is the same thing, so I'll get that, put it here. Any of the jumps or anything that requires labels. Gen label again, that's not going to be in the thing, so I'll still generate it as a nope instruction though. Okay. All right, this is the same thing. Function call. So this is okay. Now so that push gen x first, that's gonna be a bit different. Gen mul, and then we do that. So inst alec. Alright, with no operator. Push and alec again. Kind of interesting how I handle that, but okay. And gen dupe. Dupe, okay. Push add and 2vp. That could really be a function in itself. 2vp. Right? Oops. Okay. Roof. Current success. Another reason why C is superior. Yeah, it does take quite a bit longer. Rust as well. Is C++ LLVM? Like, is that the standard one that it compiles to? Because that could be part of the reason, right? Because I know Rust is, right? I have not used C++ enough to know, but like G++, right? That's the compiler. Does that use LLVM? Or it's just Clang that does? Because I know Clang does, but and those are all separate functions, so we're good. Okay, so I think that was it for those. Let's see. Is there anywhere else where we print that? Outlook. Okay. No clue. Okay. I could look. Fine. Source assembled chess game 2, and it took 5 minutes. Dang. Yeah, so where is G? Is that here? Are you using G++? Or was it for that? Was written in Rust. Yeah, well, Rust, everyone knows that Rust takes a while. Is this? I don't know how to find out. I don't know. I do not know. Yeah, okay. And 2 right. Okay, and the last one. Okay. And let's keep going. The only thing you've installed. Okay. So help. G++ or LLVM. I don't think so. I guess. LLVM G++. Alright. Okay. That's Apple specifically. Clang does. Okay, I'm assuming not then, but I don't know for sure. Is there more print right here? So this, what is that? The type. How does that work? Oh shoot, okay, I see. So it is the yes, that's gonna be a bit different because it's not. So where do I have OP types? Right, basically I'm gonna generate it, but this is going to be based on the type instead. So it'll be a different one of these. The types inst expert .win.ip.type. So I can do that with types. I can have OP types inst and just replace them with inst add inst sub inst mul is y equal line. C++ is probably has too many features. Do you have English? I know grammar. Yeah, I mean, that's kind of the thing, right? That's the thing with it is too many features. Shoot, what's this one? Compare not equal. Okay, let's compare not equal. Compare greater equal. Compare less equal. Compare greater. Compare less. Okay. So I'm a programmer, I read this code and go like, okay, sure. That is how I feel while I'm writing it, actually. The same way. That's one of the reasons it has a deep learning curve, for sure. For sure. Low level range full of functionalities must be MS, so C is the only way. What's the next one? Alright, so this is that, and then we have this, again, push stir, push char, or print out. Alright, these are labels, so those don't matter. Alright, so I think we might be almost done. Alright, native, so we have that, since this is a native one. So this is inst native. And then this, it actually has nothing. So as int equals, what is the value? Node value.native.type. Okay, and the data type, I have to do that. Let's take type int regardless. And should be good there. How do you handle viewport change on Kano? When I resize just a bit my application, it becomes a mess. Is there a function like isChange? Does it not do that? Usually it does for me. Like, it gets cut off on the side, but that's because there's less room there. I mean, it works for me, so I don't know. It's not a mess, and then it goes back. So I don't know why it would be. Maybe it's a floating thing. Could that be it, actually? How do you make a floating window? Hang on. There we go. Yes, it does not become a mess for me, so I don't know. Don't know what to say. There is yeah, there's a few different ways you can handle it, so I can open it up. Shoot, I do not want floating. There we go. Okay, let's see. I can open Kano. Yeah, is term resize. Yeah. So I mean that should be handled, but is term resize. Yeah. Let me do this. So I do not know why it would not work. I know not. Oh, your application. I thought you were saying with Kano. Okay. I didn't understand the question. Yes, okay, I see that now. That is my bad. I thought he was saying he was using Kano and that would happen. But yeah, that is the function. Is from type. You can also, it also counts as a key press. You can also just detect the key press if you wanted to. I don't remember what that's called. So there's two ways to do it actually. Where is... Okay. Ah, okay. Why do I not just gen pop? Oh yeah, because I don't want to change the stack size. So let's actually let's see that instead. Save file, and then right, because I do not want the stack size to change. That is why I did that. I say for your demonic purposes. Okay. My bad. I do not understand. Here is. Where is that? With the DA up here. Right here. And where was it? Right here, yes. This is inst-direct. 0. And type. What's that? That's really things that much, so I don't know how to. Well, yeah, that was actually just that was my fault because I read it. And I read it wrong. Like I did not see that you said just a bit in your application. So that was entirely on me. Whoops, and I missed one there. I don't understand why I don't have a function for that, but okay. Alright, there is one. So push float. I think no, I did not. Alright, so let's see if that compiles. Let's see where it does not. Type in. It's supposed to be in type. So int type. Int type. Type. Okay. Type red. That is entirely wrong. What the heck? This is just 0. Okay. I just found out there's a cool emoji picker for Ropi. Really? Emoji? I just use D menu. Or is it Rofi? Rofi or Rofi? I don't know. What? Oh, copies the selected emoji to the clipboard. Okay, that's actually pretty cool. I like that. That is actually very cool. Okay. Okay. That is cool. Probably like emojis are hard. Rofi, Rofi is the thing you were using instead of daemon. Okay. Yes, I've heard of it before, but I don't know if I've used it. But that is very cool. Very cool. So what is this? 84. Nope, 384. And I did that wrong. So that is what? Types. Types. Wait, this is supposed to be a inst. Someone tried using Unicode in C. I find it difficult, especially with end curses. I have not, so I cannot speak on that. Yeah, character, yeah, it is. It would be even cooler if it had GitHub emojis so you could paste them into commit messages. Yes, that would be very cool. Just gonna have to implement that yourself. Yeah, I haven't tried to do anything with Unicode, so I cannot speak on that. Inst set, that is what I meant. Okay, inst mol, that is incorrect. There. In there, so state undeclared. So we need to pass the program state. Uncreatable, so we need to pass state. Alright. W char t. Yeah, okay, well, hang on. So, surely, like, it supports it, right? Do you have to? Oops. N curses W? Perhaps that could be something to look into. Too few arguments type J. Did that not work? Shoot, actually I need to change the header file. Okay, what is that about? 53. Okay, DA append. State unclear. So that's the same thing. 49. State. Alright, so I think I have a few of those. Alright, I guess only 2. Alright, and compile that. Search for line, that is fine. Let's see, run sh. So let's do something quite simple. Not push back, I can't do that. But I can do x equals 5 and exit with x. I'm pretty sure that should work. Okay, so that did compile, and nice. It created that, but also it should have created that. So I need to now actually write the machine to the file. Get reads bytes, but UTF-8 is multi-byte. You could read that byte by byte and interpret it, but that's work. Use get to read a whole wide character. Alright. I see. Okay. What do I need to? Yeah, so I need to go here, and I want to do it here. No, in the generic. That makes sense to do it there. So I just need to then write program to file. Let's just do this again. So it's going to overwrite the file that it generates, but that's fine. I'm just going to create a TASM file, I guess. So that's maybe not great, but anyway, output and machine and a pointer to that. I don't know what else I have to pass actually. Semicolon. Does it work now? Nice. Yes, indeed. Machine undeclared. We don't have the machine. Oh, shoot, because it's a state machine. Oh, shoot. There. I don't need that. Undefined reference. Why is it undefined? Is that not what it's called? to file. Okay, so I'm getting some linking stuff here. Okay. So what if I do it in here? In H. Let's see. Dot machine. I did it actually out Tim. Not begin on. It looked like it was nothing. Yes. Okay. So it wrote nothing. Pretty much. Fire. Execute 0. So that is not right. Should be exiting with 5. Okay. So state dot machine. Alright, so I think I forgot to give some information to the machine perhaps. That is necessary. So let's look at the machine. So the entry point, that's assuming zeros, that's fine, we don't need that. The memory, that is fine as well. Program size. So I think we might need that. Because I believe we use that. Alright, let's look at this. So what do we need? We need the string size, that's gonna be zeros, that's fine. The entry point. But that's only if it has an entry point, right? Yes, we need the program size. That's the issue. So the program size chain equals chain by instructions. Dump. Dot. Okay, that looks like one. And it did say 5. Okay, okay. So we can't do anything with strings or characters at the moment, or jumps, right? So it's a bit limited, but we can do a few things. Added where? Yes, yes indeed. It's much better actually with that, so I probably will start using that from now on. Let's run that, and 15. Okay, okay, and that is correct. So yeah, so we can generate directly the bytecode. That is quite nice. For some programs, right? Obviously it is limited, right? So let's see. For the strings, what I need to do is have push onto the string stack, the current string, and then for that we need to also we need to push the index, right? So when we do push stir, we provide an index in the string stack essentially. So that might not be too hard to do. But I'm going to be right back before I do that. Give me about 3 minutes, and I'll be right back. Okay, I am back. JavaScript string just in the bytecode. Yes, that's how this works. But it reads it from the bytecode, and it has to read it into an array, right? Oh, or some way to store it, like to get it at runtime, right? But it is in the bytecode. Like if I take a look at, say, go here, take a look at what it will want to know. You can see where is it? Maybe I don't have any strings in this one, do I? Man, one of them has strings. Let's see. Good. Go out of here. Test mechanism. I can modify that, and I'll do push through. Hello. Right, and that is going to be in the bytecode. So if I then compile it, you can see the string right there. Because it writes it into that. Okay, yeah, I think what I want to do first is commit that. Some of the a subset of directly into. Okay, that's a lot of insertions. It's because I copied the file, so that is why. Okay, so what I need to do is go here and push storage. So basically, I need to append. We have the string stack, so we can just do da append to state machine string stack, and actually can't do that yet. Yeah, so I need to modify this thing. String stack. Is that what it's called? String stack. Yeah, so it's like this. I don't like that, so I'm going to change it. So instead, string stack string data and size to be digest. So I'll have to change some places, but that should work. This will be a stir stack instead. That's going to be much nicer to work with. So let's go here, build that. Why did it compile? Oh, there we go. Okay. Index set values. So I'm going to go out of here. Alright, so let's see. Yeah, anywhere we have the stir stack, basically. Stack.count. Data. Okay. Got it. Okay, so this is actually reading it. So yeah, but the count is what matters, right? When I open C program summaries to look for some project ideas, I see people implementing HTTP servers, interpreters, virtual machine, and other complex stuff. C is only for the true hard tryharders. Yeah. Well, I mean, you know, I think people who use C typically are doing more complex things than like making like what would be a simple thing like to you that's still a decent sized project but isn't complex, right? I think it's relative, right? Alright, does that compile now? It does indeed compile. Okay, that was not too hard. Let's go here and push stir. Simple language, complex project. Complex language, simple project. Yes. Checks out. Well, it seems simple, right? But then if you actually have to do anything, it gets kind of complex, right? That's a good way of putting it, though. So basically I need to append to the state machine dot stir stack and append the value. Alright, so we have that. And then we have to append the instruction. Well, we'll do this first. Whoops. Let's push stir. And this is as in, and this is state machine dot stir static size. Dot count rather. And this will be int. Okay. Let's get rid of that assert actually. Okay, let me try to do something with this string. So it still might not work all the way, but if I do, right, hello world. Expected token. What is that about? It's inserting like null termination. Hello world. Okay, so we get that, and then if I hex edit kno dot not kno dot but out dot thing, then we have this, and we do have the string there. It looks like. So if I go ahead and interpret that. Hello world. Ooh, that is interesting. Okay. A chess game. Okay, nice, nice. In a chess engine. All right, and you're writing it in what language? Did you say Rust, or we're talking about something else with Rust? Pure C. All right, nice, nice. Very cool. Do you have a link to it, or you don't want to share that yet? That is annoying. That's annoying. So if there's a null termination character, we need to... Not yet. All right. All good, all good. Shoot. Dang it. Test. Yeah, that is a big... Right, how do I fix that? Without iterating over the whole thing. How do I handle that in the virtual machine, right? In the assembler. Right, what is this? I don't even know what I'm doing here. It's gonna be in here. So type string. String size is that. Data is that. So we copy it over. Okay. But what about type stir? We have that. Type string. So we do that. We just have to grab the escape character. Dang. Right, and insert that instead of reading it directly. So, right, how do I handle that in here? It's all in the front end stuff. Well, actually, where do I get the string from? Extra value dot string, right? Shoot. Do we have a string? Where is this at? Is alpha? I say I have this here. So where is... Right here. Okay. Generate string. So when we generate string, what do we do? So if we do that, is valid escape. We do that. Then we want to basically just set the character to that. So I don't really want to do that, right? So I want to actually get the escape and append that instead of this. We know get escape u data. Right, instead of this. So this is going to be an else. We still want to top left. So I need to get escape. Let's go to the valid escape. And yeah, then we just get the escape. Already read about chess engines, how they work, and their mini-max algorithms. Nowadays they implement neural networks, but I am too newbie to implement one. All good, you know, you can get to that later, right? Get to it as necessary. So, yeah, I want to return. Return. New line. Return this. Probably a better way of doing this. Uh, 1 a.m. and I have to wake up at 7 a.m. so I'm going to sleep. Okay, have a good one. I will do 10 push-ups now. Done. I did it. I did it. Yes, have a good night. Can't really return false here. Return a space, I think. We already checked that it's valid though, so. And they'll do that in a second. Alright. So what is this? Get escape. I need to rename it. Assert. Oh yeah, I need to add a message. Unexpected escape character. Okay, and build. Alright. And almost. Why is there X? You know what? We must have appended too many. So there's like one empty character there or something. Let's see. If that. Oh shoot, I see. So we're doing this. Let's do that. We chop left. Right. So we append that. Yeah, so it is garbage data. So am I missing a... Ooh, the null termination. Is that what I need? Yeah, I think I don't have that, so that's probably what the issue is. So at the end of the string, we'll append that. Yeah, because it expects that to make it work well with C. It's like it's sized and it'll terminate. Okay, there we go. So we compile that and we can work with strings. Alright, alright. Right, test. Yes, alright, so it is the same output. Alright, perfect, perfect, perfect. Alright, alright, I will commit that. Then I probably about have to go. But yeah, got a lot done, so I'm very happy with that. Bring bytecode in. Okay, push that. And let's see. So yeah, basically, we have left is there's a few like to-dos, right? Cert. Unknown strike, that's on it. Let's see, assert default. So push character. So that's just interesting because we don't have the character, but actually now we might. Yes, I guess because we do that. So what if let me just try this, and then I will have to go. Equals, data 0. Alright, let me take a look at that. Oops, Tim. Okay, no, tree. And Tim.data. Let's see, exit. Okay, like that. 65. Okay, so it looks like that worked actually. Yeah, because now it is an escape character. So before I couldn't handle that, but now it's just one character. So what's that actually do? So that is good. What else was it though? There was, I think it's just the labels now. So basically what we have to do is keep track of the current size of the instructions, which we do have, so we can keep track of those already. And then we just have to use that as the where we're going to jump to for the label, right? So we'll have some sort of label stack. We'll push onto it, and then we'll get the name of it, right? Because we'll pass the label like that, right? What is this actually? Oh, I see. So that's the label number. So we need to keep track of it in that way. Yeah. So it shouldn't be too hard. That's just the most complicated part of actually transitioning over. So I will commit that. Fix characters in string. Alright, push that. Yeah, so we're getting there. So we're almost independent of the actual assembly. So that is extremely nice. Nice to have. Okay, so I think that's gonna be about it. So thank you guys for watching, and I'll see you next time. Bye.